The next topic in our lecture series is arrays, and also we're going to talk about collections. They're sort of the same thing. I didn't really feel like making a big deal out of collections right away. Arrays is the simpler thing that most people have heard of if you've had any sort of beginning programming course, especially in something like maybe C. You would have learned about arrays, and you can just think of them as collections of like data, so the same kind of data. I've got 3 chocolate chip cookies on the screen. The takeaway here, the hidden metaphor, is that they're all the same kind of cookie. So I can have 3 different things in one variable and have basically a list of things as long as they're all the same kind. But the other thing to remember about arrays is it's what everyone wants at work. Hold for applause. All right, moving on. So the way I like to explain arrays is a grocery list. So if I'm going to make a grocery list, I'm going to go to the store and buy eggs. I'm going to buy some milk. I'm going to buy some cheesy poofs, maybe some bread. Heaven help me, I need some deodorant. So these are the things I'm going to get at the store. And it's a list. And so we've all seen lists before. So I'll take it one step further when I'm talking about my list as an array. I want to pay attention to the position of each item. So the first item in the list is eggs, the second is milk, the third is cheesy poofs, the fourth is bread, the fifth position is deodorant. But you have to remember when you're talking about arrays, and programming in general really, but especially arrays, that computers don't start counting at 1 the way normal people do. They start counting at 0. So you have to bear that in mind. So let's look at our list from the viewpoint of a computer. If we were making this as an array, we would have eggs at position 0, milk, cheesy poofs, bread, deodorant, etc., each in a numerical position beginning at 0. All right, so that's the gist of how these things are going to be working. And really, that's the biggest thing you have to remember is that everything works based on a position. So let's take a look at what an array looks like. An array is an object, which means you have to instantiate it using the new keyword. It's going to have properties and methods on it, and all different kinds of things that you can do with an array. But just taking a look at how it's instantiated, the sort of reddish letters on the left side of this where we're creating the variable called myArray, that's pretty common, pretty straightforward, right? It could be named anything you'd like, and then the var keyword is just, again, going to instantiate it as a variable. And because of implicit typing, we can get away with saying var instead of the type, because it's going to infer the type based on the instantiation, which is, of course, on the right side, the blue area. And so we're instantiating a new string. And in this case, it's not a new string because of those square braces at the end. So this might be a little confusing. You're used to seeing parenthesis there. That's not a parenthesis. Those are square braces. If you look on your keyboard, your square braces are next to the P key on your keyboard, and I guess above I guess that's the comma, or no, it's an apostrophe. So they're right there above the apostrophe and next to the P key on your keyboard. Those are the square braces. And anytime you see a square brace, you know that you're working with an array or a collection. It's sort of a dead giveaway. So that's the thing that's a little bit tricky about this, is instead of parenthesis, when we instantiate a new array, you're going to see those square braces instead of parenthesis. All right, so the other thing that you need to know about arrays is that they have a fixed size. So here we're creating our grocery list as a collection or an array of strings, and we're saying that there are going to be 4 in there. So this is the thing about arrays. You have to know the size ahead of time, and they can't get larger or smaller. So here we're saying that we're creating this thing with 4 spaces in it, and if we decide to add more to the list, then what we'll wind up having to do is we're going to have to make a different list under a different variable name, make it larger, and then copy in the contents of this one. And so it gets a little tricky if you need something that can resize itself. This isn't the best choice. We'll see a better choice a little bit later when we talk about collections. But for now, let's focus on this because the way that we work with arrays is pretty much the same as the way we work with all of the other array-like types, i.e. collections. So everything is done, as I mentioned, by numerical position, and the numerical position is always enclosed by square brackets. And you see here that we have 0 here. I just wanted to highlight that position. I made it green so that you could see it next to the curly braces. And that's pretty much the key to the kingdom. You can get anything out of your array if you know its position. If you know how many things there are in an array, you can go through and find all of them. You can work with everything in the array. There are a lot of cool things that you can do with an array, especially when we talk about loops, which is the lecture right after this one. But for now, just focus on the key topics, which are the name of the array, in this case, grocery list, the index, which is the position within the array, and that index is a number, and it's enclosed by curly braces. So the next thing you need to know about arrays, especially with respect to C# or whatever language you happen to be evaluating, you're trying to learn, is whether or not arrays are dense. Array density just means, well, pretty much what you're seeing on the screen here. You're looking at an array that is not dense. And what I mean by that is you can see that the indices aren't necessarily in order. We start with 0 with our eggs, and then we stuck our milk in at position 100, our cheesy poops at position 225, and deodorant at 316. These are all just arbitrary numbers that I made up. The size of the array is not changed, right? There's still 4 things in the array, but positionally speaking, we would have to make space for 317 items because the highest index in this is 316, and of course 0 adds 1 to that, so we would have to have 317 spaces. And that's what I mean by array density. Can I get away with making this a size of 4, or do I have to make it 317 and fill in everything that's intervening? In C#, arrays are dense. You can't get away with just making one like this with 4 things in it and then just have arbitrary numbers in there as your indices. There are languages where you can do this, JavaScript being probably the most obvious example, but that's the question to ask as you're learning a language with arrays, and pretty much all of them have arrays. Are the arrays required to be dense? In C#, the answer is yes, they are. Now, there may be some strange types buried deep down in the guts of C#, or maybe a third-party library that you can use if you wanted non-dense arrays, but the stock arrays that come with C# are dense. Okay, let me show you a neat little trick when you're initializing your arrays. You can use something called a list initializer. And this is nice because it does a lot of work in one line of code. So here I'm creating an array of strings called weekdays, and I'm automatically instantiating it with what's called a list initializer. And it's probably pretty obvious what that does. So we're initializing, let's break it down. Initializer is what we're initializing with, and then of course it's a list. And so with this, I don't need to tell C# how many things that I want to put into this, because it knows. It knows based on the initialization. It knows that I want 7 things in it because there are 7 things in the list that I'm passing it. Just remember that the list initializers are enclosed with curly braces rather than square braces. Unfortunately, this gets a little confusing. I apologize for that, but I didn't create the language. I just teach it. So here we are with curly braces as a list initializer. So when you're seeing that, that's what it really is. So beyond that, everything works the same way. In this case, it's going to initialize Sunday at position, or sun at position 0, mun at position 1, 2 at position 3. That's confusing. You get the idea, though. Each thing is positionally in the array because of its position in the initializing list. So if you can make pretty much anything a list, you can make a list out of pretty much anything you want to. It stands to reason that you should be able to make a list of lists, right? So there's a special term for this. When you make an array of arrays, or a list of lists, if you prefer that term, they don't necessarily have to be the same size. They don't have to have the same number of things in them. I'll show you an example in just a minute, but I wanted to point out this because I know it's on the exam. I ask a question about jagged arrays, and this is what I'm talking about. It's just an array of arrays, and the reason why they're called jagged arrays is if you look at them, say, printed off, they would look jagged. See how that edge sort of looks kind of jagged, especially if there were hundreds of these things, different lengths. That would be definitely sort of this jagged, almost like you tore off a piece of paper on the edge. And that's where we came up with the name jagged array. Okay, so this is an important topic, so I kind of want to really hit these basics over and over again. Just to sum up what we've got so far, arrays are really just lists. There's a numerical index that explains the position of the item in the list. You need to remember that in C#, arrays are dense, meaning you have to have all of the positions in order. And C# arrays are type safe. We didn't say that explicitly, but pretty much everything in C# is type safe. So that's a pretty safe bet. If there's an exam question asking you whether or not arrays are type safe, then the answer is, of course, true. Okay, so that's arrays, and they're sort of the most basic form of collection that you can have. Let's move on to the more complicated and probably, in my opinion, more useful sets of collections that you can use. And there's two things that we need to talk about with respect to collections, and that's collections and generics. They're related, but they're separate concepts. So let's take these into consideration. We'll start with collections, and they're really just more complicated forms of arrays, but they're nicer, in my opinion, again, because they can grow and shrink at any time. Now, of course, anytime you make things more complicated, more robust, more usable, you're also increasing memory footprint. So if you're worried about conserving memory and using the smallest amount of memory possible, then an array of strings is going to be smaller in memory and potentially faster to work with in terms of computational time than will be a collection of strings. But if you don't need to worry about any sort of probably microsecond penalties, definitely sub-second penalty with respect to what you're working with, I guess really the only time it would come into make things into a bad condition for you would be is if you had a really, really large collection. And I've worked with some really large collections with millions of items in them. And sometimes it might make more sense to use arrays when you're talking about big collections of things. But most of the time you're not. So the collections classes are actually a lot nicer. Again, because they can grow and shrink anytime you want to. And they have useful methods on them that allow you to process, find elements. There's even something called language integrated query. I should have made a slide for that, but I didn't think of it until just now. It's called LINQ, language integrated query, that allows you to do a lot of cool manipulations with collections. And when we combine a collection with loop, which we'll do in the next lecture, it becomes one of your more powerful tools with respect to programming. So let's take a look at an example of what a collection looks like as opposed to an array. An array was pretty straightforward. Collections are too, but they do look a little bit different. So we've got, in this case, a variable which is going to be a list of strings, and you can see that string is defined there with these angle brackets. We'll look at that in just a minute. And we do actually instantiate lists or collections, most of the more complicated collection types, with parenthesis, which is different than what we did with an array. We use the square brackets with the array. Here we're using parenthesis. And again, this goes back to the fact that we can resize a collection pretty much anytime we want to. So here's the syntax that we're using for adding things in. It's just a little bit different than what we did with arrays. So we're using the .add, which is part of the object, the list object. So we're adding things in, and that's pretty straightforward, I think. I'll point out that list initialization works the same way as it does in arrays, so you can use the same kind of list initializer that we talked about a minute ago. Just remember that they are enclosed with curly braces rather than square braces. All right, a new term I want to introduce you to is dereferencing. So we've sort of hinted around at it. I may have even said it just out of sort of muscle memory. Dereferencing, I get a lot of students say, what do you mean by dereferencing? What I mean by is I'm getting a value out of a variable in this, or it could be a collection. In this case, it's a collection. I'm getting something out. So I've got all this stuff where I'm putting stuff in, and here I'm taking stuff out. So you can dereference collections using the same square braces you do with regular arrays. And I'm sorry, that's somebody trying to get a hold of me. Hang on just a moment. All right, so dereferencing just refers to getting something out of a collection or even out of a variable. So let's look at an example. If we're going to dereference this particular list, what would numbers 3 actually be? Well, remember, we start at 0. So the first one is 10, that's 0. 11 is 1, 21 is 2, and 13 is 3. So the answer to this question would be 13. So that's really the trick, is don't forget about that 0. Other than that, it's the same as it is with arrays. Just look for those square brackets and the index inside, and it's the same. All right, let's take a look at those angle braces that we've been talking about. These are generics, and this is a separate topic in C#. They just happen to go really well with lists and collections in general. In C# you can make these type-safe classes, and that's fine if you're using a type that's built in, like an integer or a string or something that everyone knows about. But what about your own objects, the types that you make in your program? Wouldn't it be nice if you could make type-safe anything, even the stuff that you create? And of course, Microsoft can't predict what you're going to create, so we need some way to do that. So the way that we handle it is with this concept of generics. And we're not going to make generics in this class. That's a little bit of an advanced topic for a beginning programming class, but we are going to use them quite often. And so the clue, the giveaway for these are these angle braces that you're seeing. They look like greater than, less than, well, they are greater than, less than signs, or the same symbol. So on your keyboard, again, it's next to the M and the / key down by your space bar. You're going to see these a lot in Unity. So we have this function that we use a lot even in beginning Unity called getComponent. And what goes inside of there is a data type. So earlier we saw that we were using a numerical index. Anytime you see an angle bracket, what we're really looking for is a type. So I'll give you an example of what that looks like. This is right out of the Unity documentation for getComponent. And in this case, we are using the getComponent call to get the hinge joint that's on this particular game object. And then once we've gotten that, then we can access hinge joint as though we had instantiated it directly and set pretty much anything we wanted to in there. So we're getting a type is the key takeaway here. So that area, that little set of text there in green, that's the generic. So anytime you see those angle brackets, a type goes there, not an index. And you're going to see that a lot. Again, we're going to use getComponent repeatedly and often. It's one of the more powerful and useful calls that you can make on a game object. The next topic I want to talk about is dictionaries. And dictionaries are kind of cool because so far we've used numerical indexes to really dereference what we want, but wouldn't it be cool if we didn't have to use a numerical index? What if we could use a key value pair, two things that go together? And it doesn't have to be a numerical index. It can be a string. It could really be anything, but most often it's going to be a string. So you're going to see those used as well. I don't have a cool example, but I want you to be aware of them and know that they exist. And I'm pretty sure I've got a question on the test regarding key value pairs. And that's what I'm talking about. I'm talking about a dictionary. It allows you to use text instead of numerical indexes. And other than that, it's pretty much the same thing. Everything works the same way. All right, so that sort of wraps up our introduction to collections and arrays. And of course, as usual, we'll have a laboratory exercise so that you can get your feet wet with it. Then I recommend you go right on in and, first of all, take the exam on collections and arrays, and then go study the section on loops, because they really do go together. You put these two techniques together and you can do a lot with them.